So now we have a PN junction diode in a forward bias. Okay, let's see. We are considering here the pre-assumptions, that is what is p-type semiconductor and what is n-type semiconductor, and then we are going to see the PN junction diode in forward bias. So first of all, the first question is that what is bias? Bias, that means some kind of externally added. So here we are going to join uh, external battery to the PN junction. Okay, there is a multiple process to get the P type and N type should be joined together and make a junction. So we are not going to go through the deeply for the PN junction. Let us pre-assumption that we have a one kind of a PN junction is available and which is connected in a forward bias manner. So what is the meaning of a forward bias? The forward bias, that means your PN junction diode have a p-type semiconductor which is connected to the, and the p-type semiconductor should be connected to the positive terminal to the battery, and the n-type semiconductor should be connected to the negative terminal of a battery, and this connection, which is nothing but a forward bias connection, or you can say that the reverse bias connection, which is reverse. So p type should be connected to the negative terminal and n type should be connected to the positive terminal. Now during the formation of a PN junction, there will be some kind of a diffusion of electrons from N to P and holes from P to N. So we get the depletion region which have a some kind of a voltage or electric field. So in the resultant electric field or a main electric field which has a direction which is in a P to N way direction, and we have a depletion region which has a electric field which is different from a actual electric field, that is also a P to N. So we can say that the direction of a electric field is P to N, and but due to the depletion region there will be the electric field direction should be P to N. That means your direction should be in this direction, and actual direction is your in this direction. Okay, so you can see that now we are going to connect this PN junction diode to the forward bias condition. So if we are going to connect forward bias uh, connection to the PN junction, we are going to observe that the depletion region of a PN junction should be decreased. So what is the reason behind that the depletion region should be decreased? So that means if we are going to apply this external voltage to the PN junction diode, your electrons should be moved to the electron movement are available there. So due to the electron movement are available there, so we can see that the electrons and holes are should be combined, as well as in the n type as well as the p type, the electrons and holes should be combined. So due to this combination we have a decrease of a decrement of a depletion region. That is we can observe that your depletion region should be decrease. Okay, and it will be at last it will be at a zero potential, then it will be the conducting manner. Okay, so at last we are going to see that now we have a characteristics of a forward bias, that is I versus V graph has been shown by me. So you can say that what is the threshold voltage? It does not mean here we are going to see that there is a we are going to apply some voltage, but we did not get any kind of a current. Why? This reason is that we have a depletion region, and we are going to apply the voltage to overcome this depletion region to overcome this voltage. This voltage is utilized to overcome this depletion region voltage. Then if we do not have any kind of a depletion region, then we get the current which is in a exponentially manner. So we have a graph which has a exponentially characteristics. Okay?